Hey everyone, welcome to our lesson on graphing rational functions. Rational functions have the form f of x equals a over x, where a is just any real number. So to start off, we want to take a look at the parent graph of this type of function. And one thing that's going to characterize the parent graph is that it's going to have asymptotes at x equals 0 and y equals 0, always. And I want to show you what that looks like. An asymptote line is just simply an invisible boundary that our function will never cross, but it is approaching. I'm going to try to put these asymptote lines in. I'm sort of putting them just to the side of the x and y axis, but they're supposed to be right on the axis. I'm putting them to the side so you can see them better. So 1 over x here. If we made a table of values of x, y values and plotted them, you would get a general picture, something like this. I'm just going to show you the general shape. The parent graph is going to have the left-hand side, which is decreasing, the right-hand side, which is also decreasing, and it cannot touch these middle lines of x equals 0 and y equals 0. So it's going to kind of curve around those. So there's two parts to it. So when we start looking at changing this parent graph, maybe stretching or adding in shrinks on the graph, we need to take a look at what's going to cause that. Remember, the parent graph function is f of x equals a over x, a number over x. So what's going to cause a stretch? Let's take a look here. If our function is going to have a stretch, if it's going to be kind of pulled more in the y direction, then you're going to notice that that a value is bigger than 1. And just the opposite, if that a value is between 0 and 1, so typically your fractions and decimals here, that's going to cause it to shrink instead. It's going to kind of look like it's compressed more towards the x-axis, like it's being weighted down. If the a value is between -1 and 0, then that's going to cause a reflection and a shrink. And if that a value is less than -1, that's going to be your reflection and stretch. So basically, to sum this up, if you have a whole number, that's going to cause a stretch. If you see that the number's between 0 and 1, that's a shrink. And if you see any type of negative sign in front, that's what's causing the reflection. And that's basically the same for every parent graph. Those types of things cause the stretching and shrinking and reflections. Let's take a look at an example here. So we do have some other things going on, some other translations, but I just wanted to show you what it could look like. So we see here f of x equals, we've got our number over x, it's an 8, it's bigger than 1. So that, if we were to go put that picture on our graph, it would look similar to the one you just saw, but it would be stretched more in the y direction. So maybe a little further away from the origin. Down here at the bottom, we've got an example of a shrink. We know that because our number over x this time is 0.5. It's between 0 and 1, so that's going to kind of compress it down towards the x-axis. So the next thing we want to do is take a look at the graph of what that looks like. What does a stretch look like and what does a shrink look like? So let's take a color here and let's draw this in. So our general picture is not going to change, but for a stretch, we may see something like this. Like I said, it may pull away a little bit more from that origin and be pulled up towards the y-axis, just slightly more. And for a shrink, you will see it come in more towards the origin like this. Kind of look like you're condensing it towards the origin. But in either case, you'll notice that the asymptotes are still there. They're still present. On those axis lines of x equals 0 and y equals 0, the graph will still never cross over those. It's an invisible boundary. They will just simply follow the curve around and get closer and closer to them, but never crossing. Alright, so we talked about the fact that the negatives in front of the a value are what causes the reflection. And so I've got an example here of a reflection, something you may see. The thing that makes that a reflection is the negative sign in front of our a value of 4. And I wanted to discuss the fact that no matter whether we're dealing with an x direction reflection or y direction, our picture is still going to have the same basic shape. If you think about that, the reason for that is, here's our parent graph picture again. If we were to rotate this across, let's say the y-axis first, we would be turning it around this middle y-axis line here. All right, so if you can picture that, this piece over to the right is going to come over and flip over something like that, and this piece down here on the bottom is going to go over like this. Okay, let's go back to our parent graph, draw it in again, and suppose we had an x direction reflection instead. Get a different color to take a look at that. An x direction reflection would be turning it around the x-axis instead, or the x direction. So if you can picture that, this piece here on the right hand side would move down and the one on the left would move up. But you can see in either case you're going to end up with the same picture. So it doesn't matter what kind of reflection we have, it will be in those other two quadrants if that is present. Alright, so I want to show you a real example of one of these graphs. Let's say that we're looking at f of x equals 3 over x. 3 is our a value. To graph, we could either use our graphing calculator, or we could make an xy chart of values and test some numbers for x and see what comes out for y. So in this case, just to make nice pretty numbers, since our numerator is a 3, it may be good to go with some 1s and 3s. So let's try something on both sides, on the negative side of the number line and the positive side. So let's try -1, -3, and then +1 also, and +3. The chart a little bit. Alright, so we're going to plug these in down here for the denominator x. So 3 over -1 is going to give us -3. 3 over -3 be -1. 3 over 1 just gives us itself of 3, and then 3 over 3 gives us 1. So nice, easy whole numbers to go graph. Alright, so we've got the point -1, -3. So now at this point we're just taking our values that we got and we're going to plot these coordinates. Second one, -3, -1. Alright, and then we've got 1, 3 here on the other side of the picture, and 3, 1. Now you remember the parent graph, what it needs to look like. It's got that curve on the left end decreasing, and same thing on the right that's decreasing. So we're just going to fill in the rest. We could continue to test values to get a really nice accurate picture of where this line is coming in, but in any case we know that it is not going to cross over the x-axis, so we can get a pretty good general picture just from our 2 points here, knowing what the parent graph is supposed to look like. And we also know that that a value gave us a little bit of a stretch because it's bigger than 1, so you can see that it's a little further away right here from origin. So this concludes our lesson on graphing rational functions.